Hello, my name is Jeremiah and this is my Physics Lab Report number 1 for Intro to Physics 2211 at Georgia Tech. Let's take a glance at the topics that are going to be covered in this lab report. We'll start out with an introduction to the lab. I'll explain the different physics concepts at play. I'll dive deeper into the process of the experiment and the coding, and then I'll explain what you just saw in the conclusion. It's time to begin with the introduction to the experiment. The purpose of this experiment is to observe an object going at the same speed with no change in direction or constant force. I did this by comparing a computational model I made on GlowScript to an object that I tried to push at constant force. There are some things we should assume before I go on about explaining this experiment. This experiment takes place on a flat surface. Motion will only take place on the x-axis, and friction and air resistance are assumed to have minimal effect. Now that we know the basics of our experiment, let's get into the physics laws and forces that are at play here. There are two important fundamental principles that are at play, those being Newton's first and second laws. The first law states that the velocity of an object won't change unless acted on by another force. The second law states that the acceleration of an object is dependent on the object's mass and the net force acting on the object. The equations that are going to be used to calculate the results and to show the two fundamental principles are the position update formula, R final equals R initial plus V average times the change in time, and the velocity update formula. The final velocity is equal to the initial velocity plus acceleration times time. We have discussed the background and explained the things that are going to happen in the experiment, so now we will move on to the experiment itself. First, I will describe how the experiment was set up. A glue stick with a diameter of 0.025 meters was rolled on its side in an attempt to mimic constant force. The video was then trimmed to capture the glue stick after the initial launch, when it had reached a speed that was more constant throughout the rest of the video. This video was then put into a software called Tracker, which will record its position with respect to time with default time steps of 0.017 seconds. A computational model was coded in GlowScript using the same velocity that the glue stick had, with default time steps of 0.010 seconds. This constant force was in only the x direction, and the values of the two simulations were compared. Here I will allow you to watch the cut video and get a glimpse at what the computational model looked like after it had been run. The axis was rotated on the glue stick to video so that it would only travel in the x direction, making both of these only show motion on the x-axis. Here we have the data received from both Tracker and the computational model. There are two important things to note. The predicted columns are the computational model, and the observed columns are the glue stick video. The predicted data set is also longer, but that is because it is measured in shorter time steps and therefore had more data values. Here are the initial conditions on the computational model. The initial position vector is at 0, 0, 0 because it is starting at the origin. The initial velocity vector is at 0.50100. The 0.501 is the constant velocity from the glue stick video, and it only happened in the x direction. This is the code that the computational model ran on. Here we see those two equations from earlier come into play. The Fnet divided by ball.m in the velocity update formula will equal 0 because there are no other forces causing acceleration. This means that the velocity of the model will always be the initial velocity. Next is the graph of the data that we received. As we can see, there is some disparity between the observed and the predicted positions over time. Now that we have completed the experiment and have organized the data, let's conclude by talking about what it all means. The observed line seems to overestimate the position of the true constant force shown by the predicted line. This makes sense because the computational model can be trusted for a totally accurate representation of constant force because it took place in a vacuum, in which there were no surroundings to disrupt the velocity of the system. The glue stick experiment would be less representative because it does not take place in a vacuum, meaning that the system was affected by its surroundings, such as other forces like air resistance and friction. There were some sources of error that could have taken place when doing the glue stick experiment. The rolling glue stick didn't provide constant force because of the air resistance and friction mentioned in the previous slide. The glue stick also did not roll straight. the axis was rotated to mitigate this, but it still went slightly off course. There were also likely some tracking errors when dealing with the glue stick because I had to manually plot its center of mass by eyeballing it. Now, what would happen if you were to flip the axes? I selected my x-axis to be positive to the right and negative to the left. Flipping that would not affect the magnitude of the constant force. The only thing that would be changed would be the direction, because the glue stick and the computational model would have been moving in the negative direction. Thank you.